Assalamualaikum. Today we are going to solve October-November 2024 paper 1-2 variant 9709. So our first question is, the diagram shows a curve with equation y is equal to a sine of bx plus c for x is less than equal to 2 pi and greater than equal to 0, where a, b and c are positive constant. In part A, he says state the values of a, b and c. So to find the values of a, b and c, we have to first understand y is equal to a sine of bx plus c. So first of all, we have to look for b always. B is the period of sine of x. If b is equal to 2, so we have to divide 360 degree or 2 pi by 2, we get 180 degree. It means sine curve repeats itself 2 times in the 360 degree or 2 pi. If b is equal to 3, sine curve repeats itself 3 times in 360 degree or 2 pi. Here in this diagram, sine curve is repeated 2 times in 360 or 2 pi. So the value of b is equal to 2. A equals amplitude. Amplitude is always measured from the baseline, and the baseline here is in this diagram is y is equal to 3. You can see I have marked the baseline with the blue color and I have written y is equal to 3, its equation. So this is the baseline. So count units from y equals 3 upwards or downwards to find the value of a. So if you count it, so you will find out there are 4 units from 3 up. From 3, the curve goes up to 7. So it's 4 units from 3. So a equals 4. C is equal to the baseline at which the graph is symmetrical. So C is equal to 3. So that's how our part A finishes. And in the next part B, for these values of A, B and C, determine the number of solutions in the interval from 0 to 2 pi for each of the following equations. So over A sine of bx plus c equals 7 minus x. I can write y equals 7 minus x. 7 minus x shows it's a straight line. So we have to just plot 2 points on the graph. So if I put x0, so I get y7, and if I write 7 in x, so I got y0. So x0, y7. So this is the red marking on 7. You can see this is here x is 0 and y is 7. So the next x7 and y0. So x7 is actually, this can come after 2 pi. So I have marked this red dot somewhere here. So join these 2 points and find out how many points are there from on the graph where this straight line, red line, is crossing the sine curve, which is in the black. So there 1, 2, 3, 4, 5. There are 5 points at which this straight line is crossing the sine graph. So I can write number of solutions is equal to 5. In second part, a sine of bx plus c is equal to 2 pi bracket x minus 1. So I can write y in place of a sine of bx plus c. So y equals 2 pi x minus 1. 2 pi x minus 1 is again a straight line. So let me find out. If I put 1 in x and I solve it, so I got y0. So x1 and y0. Let's see where it happens. So on the x-axis, before pi by 2, I have circled with the blue. This is the point. You can say this is x1 here and y is 0 here. So mark 1 point here, and the other, if I place 0 in x, I got minus 6.2 y. So I extended the y-axis with the blue line. So this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and a little ahead of minus 6 I marked with the blue dot. So here my x is 0 and y is negative 6.2. I got 2 points, so I join them and I draw a straight line with the blue color. So this line I have written at the end of this line y equals 2 pi bracket x minus 1. So this line is crossing the sine curve which is in black at just one point. So I can write number of solution is equal to 1. So that's how this our first question finishes. Now come to the second question. In the second question, the first term of an arithmetic progression is minus 20 and the common difference is 5. Part A. Find the sum of the first 20 terms of the progression. The formula which is always given in the paper on the formula sheet, Sn equal n over 2 bracket 2a plus n minus 1 times t. So we have to find the sum of first 20 terms, so put 20 in n. So 20 over 2, 2a is over minus 20. He said the first term of arithmetic progression is minus 20 plus n minus 1 means 20 minus 1 times d is also given, which is 5. Now simplify this, you will get S20 equals 550. This would be your answer to part A. Second part, find the value of B. It is given that the sum of the first 2k term is 10 times the sum of the first k terms. So you can write 2k equals 10 times sk. For n is equal to 2k, you can place the values in the formula. Wherever you see n, you have to write 2k. So 2k over 2, 2 times minus 20 and plus 2k minus 1 times d is over 5. Now if I solve it, I will get 2 and 2 will be cancelled. So k times minus 40 plus 10k minus 5 and further I should also simplify this for 10 times sk. So this is equal to 10 times sk, means I have to write k in n. 20 plus k minus 1 times 5, and if we simplify this, we get 5k minus 40 plus 5k minus 5. So k times 10k minus 45 equals 5k. So 5k minus 45. So this will become 10k minus 45 is equal to 5k over k times 5k minus 45. You will get from here 10k minus 45 equals 25k minus 225. So minus 45 plus 225 is equal to 25 minus 10K. So this becomes 180 equals 15K. So K equals 180 divided by 15, which is 12. So this would be our answer. In question number 3, the equation of the curve is y equals 2x square minus c. 2 points A and B with x coordinates 2 and 2 plus h respectively lie on the curve. Find and simplify an expression for the gradient of the chord AB in terms of h. So equation of the curve is given y equals 2x squared minus 3 and the x coordinates are 2, 2 and 2 plus h. So find out the y coordinates also. So y equals, first put x is equal to 2 in x. So 2 into 2 squared minus 3. So you get y equals 5. So let's say A has the coordinates 2, 5. Now work for B. So again use the equation and put 2 plus h in x. So it becomes 2 plus h whole squared minus 3. So if you simplify this, you will get y equals 2 times 4 plus 4h plus h squared minus 3. This gives you y equals, I'm writing it directly in simplified way, 2h squared plus 8h plus 5. So the coordinates for B I can write 2 plus h, comma, and my y is 2h squared plus 8h plus 5. Now you can use x1, y1, x2, y2 and use the formula of the gradient. We write m for gradient. Gradient of AB equals y2 minus y1 over x2 minus x1. So y2 is 2h squared plus 8h plus 5 minus y1 is 5 over x2 minus x1 means 2 plus h is my x2 minus x1 is my 2. When you simplify these, like you see these 2's are gone, these 5's are gone, so you are left with 2h squared plus 8h over h. If you take common from the numerator, you get 2h bracket h plus 4 over h. So h are gone, so you can write the gradient of AB equals 2h plus 8. That is your answer for this part. Explain how the gradient of the point A can be deduced from the answer to part A and state the value of this gradient. Okay, if I make a small diagram for this, suppose if my A is here and my B is here, So if I join them, so this is a secant. This line is called the secant. So if I bring it down towards A, finally it makes the tangent with A. So as B is moving towards A, H decreases its distance from A and eventually becomes 0. From part A, gradient of AB was 2H plus 8. Now put H equals 0 in this gradient. So I can write it was 2H plus 8. So I'm going to place 0 in H. So I get 8. So our gradient at point A would be 8. Actually that secant becomes tangent, and this gradient 8 is the gradient of the tangent at point A on the curve. So you have stated the value of the gradient, and I have explained in my explanation. You can write it down. So wait. My next question 4, find the term independent of x in the expansion of each of the following. So independent of x. So we use a specific term formula which is NCR a power r b power n minus r. So we have to find the value of r. So we can write our n is 6, 6CR, our a is x, x power r, our b is 3 over x square. So if I bring x square in the numerator, it becomes x power negative 2. So I can write 3x power negative 2, and my n minus r is 6 minus r. Now collect the x terms only from this. So I can write x power r times x power negative 2 whole power 6 minus r. This gives me x power r times x power negative 12 plus 2r. So this further becomes, bases are same, power must be added. So write x power r minus 12 plus 2r. Now equate this with x power 0, because we have to find term independent of x, and only x power 0 gives you independent of x, means without x, and anything else power 0, the answer is 1. So let me show you here, x power 0, the answer is 1. So I'm going to equate this with x power 0. So x power r minus 12 plus 2r is equal to x power 0. So bases are same on either side of is equal to sign, so I can equate the powers, which is r minus 12 plus 2r equals 0, and from here I can find the value of r. So my r would be equals to 4. Now put this value of r back in the formula. So you can write 6c4 x power 4 3x power negative 2 whole power 6 minus 4, and this gives you, after simplification, 15x power 4 3 over x squared whole power 2. I brought back the x power 2 in the denominator to make its negative index into positive one. So this gives me 15 x power 4 3 over. Now instead of writing 3, you can write the square of 3, which is 9 over, and the square of x power 2 is x power 4. So now you can see that x power 4 will cancel each other out, and you multiply 15 by 9, you get the answer 135, which is independent of x. In B part, 4x power 3 minus 5 times x plus 3 over x square whole power 6. Alright, so here we should be very careful in handling this. You can use the formula to open the second bracket and see where you can find out the values independent of x. So let me write the formula first. So here we are going to use a power n plus nc1, a power n minus 1, b power 1, plus nc2, a power n minus 2, b power 2, plus nc3, a power n minus 3, b power 3, plus so on. I'm guessing just that maybe in 3 terms I can find out the values independent of x. So 4x3 minus 5, and now my a is x power 6 plus 6c4, x power 5, n minus 1 would make it x minus 5, b power 1, which is 3 over x squared, plus 6c2, x power 4, n minus 2 will make it x power 4, and b power 2, which is 3 over x squared whole power 2, plus 6c3, x power 3, and 3 over x square whole power 3, plus dot dot dot, bracket closed. Now simplify further this. 4x power 3 negative 5 times x power 6 and 6c4 x power 5 3 over x power 2 will give you, after simplification, 18 x power 3 plus. Now 6c2 x power 4 3 over x square whole power 2, if you work carefully with this, you will get 135. So this part is independent of x, plus the last part 6c3 x power 3 3 over x square whole power 3 will give you 540 times 1 over x power 3 plus dot dot dot. Now what you have to do here, you have to multiply 4x power 3 with this, so that your x power 3 should be cancel each other out, and you have to multiply 5 with 135 only, because you are looking for the values independent of x. So when 4x power 3 multiplied by 540 into 1 over 3, you will get 2160 minus this minus 5, When multiplied by 135, you will get 675. After subtracting these values, you will get 1485, which is totally independent of x, and this would be your answer. Question number 5. The function f is defined by f of x is equal to 2x plus 1 over 2x minus 1 for x is less than half. Part A1, state the value of f of minus 1. So this is a very simple question. You just write f of minus 1 equals 2 times minus 1. Wherever you see x, you put minus 1 in it. 2 into minus 1, minus 1. So this would give you minus 1 over minus 3. So minus gone. So your answer would be 1 over 3. Second part, he has given you a sketch. The diagram shows the graph of y is equal to f of x. Sketch the graph of y is equal to f inverse of x on this diagram. Show any relevant mirror line. Okay. How to do this? You have to always remember one thing. You have to draw a line which is called y is equal to x. Always. So this is your y is equal to x line. You can write 1 here and make 1 as asymptote, and I will explain you in detail why our asymptote is here. And half. Write 1 by 2 here and make an asymptote here. Now this should be below your asymptote, horizontal asymptote 1 by 2, and it should be near to 1 here. This is your f inverse of x, the red one. You can write somewhere f inverse of x. The black is f of x. First of all, you have to see the range of this function. Domain is given in the equation, which is x is less than 1 by 2. Now let me explain this everything to you. For range, we have to work with the given equation. Y is equal to 2x plus 1 over 2x minus 1. Here in this equation, our degree of polynomial is 1. Take its coefficient both from the numerator and the denominator, which is 2 over 2, and you simplify it, you will get 1. Now our y is equal to 1 here. Will be our horizontal asymptote. Y is equal to 1. You can say this is over 1, and let me draw it with the green line. Actually, this is our asymptote for the f of x. Y is equal to 1. How we get it, I explained it to you. And we can say for range y is less than 1. Look at the black curve, the main f of x, the main black curve. This is our f of x and it is below y is equal to 1. So we can say the range for this y is less than 1. If the power of polynomial in the denominator is more than the power of the polynomial in the numerator, our horizontal asymptote would be always the x-axis or y is equal to 0. For example, if our equation would be x minus 1 over x square plus 2, look, the power of x is greater than the power of x in the numerator. So our asymptote would be always x-axis whose equation is y is equal to 0. So asymptote would be, x-axis. Or y equals 0. And if the power of the polynomial in the numerator is greater than the denominator, then the range would be y is equal to infinity. Suppose x square minus 1 over x plus 2. So our range would be y is equal to infinity. So you have to remember these 2 points. Now let's do part 3. Find an expression for f inverse of x and state the domain of the function f inverse. So our equation is f of x is equal to 2x plus 1 over 2x minus 1. Always let f of x equals y. Then write this equation in terms of y. Y equals 2x plus 1 over 2x minus 1. After writing this, make this your duty to make x the subject. So you multiply y by 2x minus 1 equals 2x plus 1. So this becomes 2xy minus y equals 2x plus 1. From here, 2xy minus 2x equals y plus 1. Take x common. So it becomes 2y minus 2 equals y plus 1. So isolate x. It gives you x equals y plus 1 over 2y minus 2. Now you can write f inverse of x, replace y by x plus 1 over 2x minus 2. Now look, domain is x is less than 1. So because range of function is always the domain of its inverse. For example, if I write f of 2 equals 7, look, this 2 is in the domain and this 7 is in the range. Can I write f inverse of 7 equals to 2? So look, the 7 which was range, now it becomes domain. And the 2 was in the domain, it becomes range. So question B part. Function g is defined by g of x is equal to 3x plus 2. Solve the equation f of x is equal to g of f of 1 over 4. So first find g of f of 1 over 4. So I can write f of x equals 2x plus 1 over 2x minus 1. So f of 1 over 4 would be 2 times 1 over 4 plus 1 over 2 times 1 over 4 minus 1. This gives me 1 over 2 plus 1 over 2 minus 1, and further it gives me actually negative 3. Now find out g of minus 3, and this is 3 times minus 3 plus 2, and this gives me g of minus 3 equals minus 7. Now f of x equals g of 1 over 4. F of x equals g of 1 over 4. So I can write my f of x is 2x plus 1 over 2x minus 1 equals g of 1 over 4 is my minus 7. Now simplify this. So 2x plus 1 equals 14 minus 14x plus 7. From here my x is 3 over 8. Question number 6. Diagram shows a metal plate O, A, B, C, D, E, F consisting of sectors of 2 circles, each with center O. Radii of sectors AOB and EOF are r centimeter, and radius of sector COD is 2 r centimeter. Angle AOB equals angle EOF equals theta degree. Theta radian, and angle COD equals 2 theta radian. It is given that the perimeter of the plate is 14 centimeter and the area of the plate is 10. Given that r is greater than 3 by 2 and theta is less than 3 by 4, find the values of r and theta. 6 mark question. So be careful while solving it. So area of sector, I'm going to use a formula 1 over 2 r square theta. So I have to find areas of sector AOB and EOF. This is my AOB and this is my EOF. So let's find out its area. So one over 2 r square theta, so 1 over 2 r is my r, so r square theta is my theta, plus same will go for sector EOF, 1 over 2 r square theta, and it makes r square theta total. So area of sector COD, make it green shade. So again use 1 over 2 r square theta, so my 1 over 2 r square theta, so my r is 2r, square it, my theta is 2 theta here, and this give me 4r square theta. Add them, 4r square theta plus r square theta. This is totally actually 5r square theta. And the area of the whole plate is given 10. So can I equate it with 10? So 5r square theta equals 10, and from here I can find out the value of theta in terms of r. So theta equals 2 over r square. Keep it with you. Now go for perimeter. So let me write it in red for perimeter. My perimeter would be actually OA plus RKB plus radius BC plus arc length CD plus radius ED plus arc length EF plus radius OF. Now my perimeter which is given, write it with P. My OA is my R plus my arc AB is S is equal to R theta, and it is R theta, plus my radius BC is R plus my arc length CD is 4R theta. I'm using S is equal to R theta, plus my radius ED is R plus my arc length EF is my R theta plus my radius OF is R. Now simplify all of it. You can write 14 in P because it is given. So this becomes 4R plus 6R theta. Now divide it by 2 to make it more simple. So you can get 7 equals 2R plus 3R theta. Now put the value of theta which you just found out in the previous working when you were working with the area, and you wrote theta equals 2 over r square. So can I write 7 equals 2r plus 3r times, in theta I am going to write 2 over r square. Now from here by 1r will be less, so 7 equals 2r plus 6 over r. And if you further simplify this, you will get the equation like this, which I am going to write straight away 2r square minus 7r plus 6 equals 0. Now you can use quadratic formula. Your a is equal to 2, b is equal to minus 7, and your c is equal to 6. So r equals plus minus b square minus 4ac. Wait. I have done some kind of mistake. Minus b plus minus b square minus 4ac whole over 2a. So r equals minus 7 plus minus square of minus 7 minus 4 into 2 into 6 whole over 2a. 2 into 2. So you use a calculator to simplify this. You will get r equals 3 over 2 or r equals 2. So in the question, r was greater than 3 over 2 and theta was less than 3 over 4. So take the value of r equals 2. This is your answer for r. And now for theta, use theta equals 2 over r square. So your 2 over square of 2, and after simplification you get 1 over 2, and this would be your answer for this part. Now question number 7. Question number 7, by expressing this in the form minus ax minus b whole square plus c, where a, b and c are positive integer, find the coordinates of the vertex of the graph with equation this. Okay, let take negative 2 as common. So you will get negative 2 x square minus 4x minus 11 over 2. Now create a gap between this. So negative 2 x square minus 4x minus 11 over 2. Now take the quotient of x, which is 4 here, divided by 2 and square it. So 4 over 2 whole square will give you square of 2. So add square of 2 first and then subtract square of 2. Now write negative 2. This first portion is x minus 2 whole square, and when you solve the second portion, negative 2 square, square of 2, negative 11 over 2, this gives you negative 19 over 2. So you write negative 19 over 2. Now you multiply negative 2 with the bracket and also with minus 9 over 2. So you write in this way. Minus into minus plus, negative 2 into 19 over 2 gives you 19. So this is the squared form which examiner wanted from you. So the coordinate of vertex are 2 and 19. 2 from x minus 2 and 19 is plus 19. This is the y coordinate of the vertex. Okay, to in B part, we have to find the area of the shaded region. First find the x coordinate of point of intersection of the line and the curve by equating the equations. So minus 2x squared plus 8x plus 11 equals 8x plus 9. Now minus 2x squared plus this 8x and 8x gone, 11 minus 9 makes 2 equals 0. So from here your x is plus minus 1. It means one x is negative 1 and other x is positive 1. Now you can integrate, you put the limit minus 1 and 1, upper curve minus lower curve. Your upper curve is minus 2x squared plus 8x plus 11 minus lower curve, so write it in the bracket, 8x plus 9 dx. Now simplify this, integral minus 1 to 1. So minus 2x squared plus 8x plus 11 minus 8x minus 9 dx. So minus 1 to 1 minus 2x squared plus 2 dx. Now use upper limit minus lower limit. So first integrate it, So your integration is minus 2x 3 over 3 plus 2x. Limit from minus 1 to 1. Now use upper limit minus lower limit. So minus 2 1 power 3 over 3 plus 2 times 1. This is my upper limit minus my lower limit is minus 2 minus 1 power 3 over 3 plus 2 times minus 1. So simplify this, minus 2 over 3 plus 2 minus 2 over 3 minus 2, and this is 8 over 3. This is my answer. Question number 8. Equation of circle is this, where P, Q are cos express equation in the form, this form where A is to be given in terms of P and R square is to be given in terms of P and Q. Okay. We can collect all like terms. So I can write x squared plus px plus y squared plus 2y plus q equals 0. Now send q on the other side of is equal to sign. So you write x squared plus px plus y squared plus 2y equals minus q. Take half of the quotients of x and y, square them and add them to both sides of the equation. So x squared plus px plus p by 2 square plus y squared plus 2y plus actually 2 by 2, which is 1, square of 1 equals, now add the same thing here with minus q. So I'm going to add it p over 2 square plus 1 square. Now rewrite the left hand side as the sum of the two perfect squares. Can I write x plus p by 2 whole squared plus y plus 1 whole square this side, if I try to simplify it, I can write it as p square over 4 plus 1 minus q. So this is what I can do it, and this is answer for our part A. The line with equation x plus 2y is equal to 10 is a tangent to the circle at point A, which is 4, 3. Find the equation of the normal to the circle at point A. So equation of tangent is given x plus 2y equals 10. So from here, express this in the form y is equal to mx plus c. So I can write y equals minus 1 over 2x plus 5. If you make y the subject and then simplify, you will get this. Wait, let me write 2 properly. So my gradient is called m of tangent is equal to minus 1 over 2, so m of normal would be 2 over 1, positive 2 over 1, which I can write as 2. Point is given 4, 3, so I am going to use this y minus y1 equals m times x minus x1. So y minus 3 equals 2x minus 4. So this is y minus 3 equals 2x minus 8. So y equals 2x minus 5 would be your equation of the normal. Find the values of P and Q. Okay, from part A, if I write x plus p over 2 whole squared plus y plus 1 whole squared is equal to p squared over 4 plus 1 minus q. Coordinate of center of the circle is minus p over 2 comma minus 1. These coordinates lie on the normal whose equation we just found out in B1, y is equal to 2x minus 5. So y is equal to 2x minus 5. You write minus 1 in y, you write in x, you write minus p by 2 minus 5. So simplify this, you get p is equal to negative 4. So coordinates of center of circle would be, you write 4 minus 4 over 2 comma minus 1. So this gives us 2 comma minus 1. Coordinates of A were also given 4 comma 3, and you have the coordinates of the center 2 comma minus 1. You write x1 y1 x2 y2, and now use the distance formula to find out the radius. Okay, radius would be equals to x2 minus x1 squared plus y2 minus y1 squared whole under root. And carefully place the values. You will r equals root 20. So my r square would be definitely equals to 20. So my radius is already, this part is my radius which I'm circling for you. So I can write r square equals p square over 4 plus 1 minus q. So 20 equals p squared over 4 plus 1 minus q. So 20 equals, value of p was negative 4 plus 1 minus q, and from here your q equals negative 15. Question number 9, equation of the curve is this and the equation of line is this, where kp are constant, k is less than 1, greater than 0. It is given that one of the points of intersection of the curve and the line has coordinate this one. Find the values of k and p and find the coordinates of the other point of intersection. It's pretty long question. Let's do it. So y is equal to 1 over 2 k squared x squared minus 2k x plus 2. Now put the given coordinates 5 over 2 comma 1 over 2 in x and y. So 1 over 2 equals 1 over 2 k squared 5 over 2 squared minus 2k 5 over 2 plus 2. Simplify this. 1 over 2 equals 1 over 2 times 25 over 4 k squared minus 5k, 2 and 2 will be gone, 5k plus 2. So I can get, after simplification, 25 over 8 k squared minus 5k plus 3 by 2 equals 0. Now multiply by 8 to get rid of these fractions. You will get 25 over 25k squared minus 40k plus 12 equals 0. Now you can use quadratic formula, and you can also make the factors whichever you like. If you are good in making factors, that would be more easier than to use the quadratic formula. I'm going to make factors. So 25 times 12 equals 300, and if I take the LCM of 300, so divided by 2, it's 150, divided by 2, it's 75, divided by 3, it's 25, divided by 5, it's 5, and divided by 5 is 1. So you multiply 5 with 2, you get 10. And then the rest, 5 times 3 is 15, 15 times 2 is 30. So 10 into 30 is 300, and I want minus 40 in the middle, so I can write negative 30, negative 10 gives me negative 40. I'm going to use this in the middle. So 25k squared minus 10k minus 30k plus 12 equals 0. So So from the first two expression, I'm going to take 5k common. So it's 5k minus 2 inside. And the last expression, I'm going to take 6 common. 6 5 so 30, 5k minus 6 to the 12. So make bracket of 5k minus 6 and take one bracket out of these two. 5k minus 2 equals 0. So look, your 1k is 6 over 5 and your other k is 2 over 5. So he said k was less than 1 and greater than 0. So pick k is equal to 2 over 5. Now, your 1 over 2 equals 1 over 1 plus p. Actually, this came from y is equal to kx plus p. So, what you did, 2 over 5, sorry, 1 over 2 equals 2 over 5 times x was 5 over 2 plus p, so your p was 1 over 2. So you can write 1 over 2 plus 1 over 2 is equal to 1 plus p, and p is equal to negative 1 over 2, sorry. It's better to write it after this. So p is equal to, from here if you simplify you will get p is equal to minus 1 over 2. Now 1 over 2 k square x square minus 2kx plus 2 is equal to kx plus p. I'm equating these two equations as the equation and the curve crosses each other. So from here simplify it. 1 over 2 k square x square minus x square minus 2kx minus kx plus 2 minus p equals 0. So 1 over 2 k square x square, might take x common. So 2k plus k is 3k plus 2 minus p is equal to 0. Now put k is equal to 2 over 2 over 5 and p is equal to minus 1 over 2. So 1 over 2, 2 over 5 whole square x squared minus x 3 times 2 over 5 plus 2 plus 1 over 2 equals 0. So this is your 1 over 2 times 4 over 25 x squared minus 6 over 5x plus 5 by 2 is equal to 0. Further simplification will give you 2 over 25x squared minus 6 over 5x plus 5 by 2 equals 0. So now here you have to use quadratic formula because it's difficult to make a equals 2 over 25, b equals minus 6 over 5, and c is equal to 5 over 2. So x is equal to minus 6 over 5 plus minus b square minus 4ac means minus 6 over 5 square minus 4 times 2 over 25. C is 5 over 2 over 2a. 2 into a was 2 over 25. Use your calculator, you will find out x equals 25 over 2 or x equals 5 by 2. So put this in the equation y is equal to 2 over 5x minus 1 by 2. So y is equal to 2 over 5, 25 over 2 minus 1 by 2. Your y is equal to 9 by 2. So your coordinates are 25 over 2 comma 9 by 2. This would be your answer. Pretty long question. In B part, it is given instead that the line and the curve do not intersect. Find the set of possible values of x. Okay, so our discriminant b square minus 4ac would be definitely less than 0. So equate these equations again. So 2 over 25x squared minus 4 over 5x plus 2 is equal to 2 over 5x plus p. Now you multiply by 25 to get rid of this fraction. So it will become 2x squared minus 20x plus 50 is equal to 10x plus 25p. So further 2x squared minus 30x plus 50 minus 25 p is equal to 0. So your a is equal to 2, your b is equal to minus 30, your c is equal to 50 minus 25p. Your b square minus 4ac, this is the discriminant, is less than 0. So minus 30 squared minus 4 times 2 times 50 minus 25p less than 0. So this is 900 minus 400 plus 200p less than 0. From here, your p is less than minus 5 by 2. Question number 10. A function f with domain x greater than 0 such that f prime x means differentiation, is this. It is given that the curve with equation y is equal to f of x passes to the point 1, 0. Find the equation of normal to the curve at point 1, 0. So points are given. So your gradient of tangent is actually given 8 2x minus 3 power 2 over 1 by 3 minus 10x power 2 by 3. So what you do, put x is equal to 1 in this. So 8, 2 into 1 minus 3 power 1 over 3 minus 10 times 1 power 2 by 3. You simplify this, you will get minus 18. So m of normal would be equals to positive 1 over 18, reciprocal of the gradient of the tangent. So y minus y1 equals m into x minus x1. So y minus 0 equals gradient is 1 over 18. I'm trying to find out equation of the normal x minus 1. This 1 and 0 was given, the points, coordinates. When you simplify this, you will get 18y equals x minus 1. This is your equation of the normal. Find f of x. So f prime x is given. F of x means we have to go back. So reverse process is always integration. So f prime x equals 8 2x minus 3 power 1 by 3 minus 10 power 2 by 3, 10x power 2 by 3. So now you integrate y equals integral of 8 2x minus 3 power 1 over 3 minus 10x power 2 by 3 dx. So y equals 8 2x minus 3, add 1 in 1 over 3, you get 4 over 3. Now you divide it by 4 over 3 times you go inside the bracket in the numerator and differentiate it. So differentiation of 2x minus 3 is 2, write it here, minus 10x, you add 1 into over 3, you get 5 by 3. Divided this with the same 5 by 3 plus c, because there is no limit, so you have to write c. Now simplify this, y is equal to 3 2x minus 3 power 4 over 3 minus 6x power 5 over 3 plus c. You were given the point 1 comma 0, put those coordinates here, 0 in y and 1 in x. To find out the value of c, so from here c would be equals to 3. So your equation would look like this, y equals 3, 2x minus 3 power 4 over 3 minus 6x power 5 over 3 plus 3. In C part, it is given that the equation f prime x equals 0 can be expressed in the form this. Determine, making your reasoning clear, whether f is an increasing function or decreasing or neither. So put any value of x greater than 0, because in the equation domain was written x is greater than 0. So let you say x equals 3. You can put the value of 3 in the differentiation, which is f prime of 3 equals 8 times 2, 3 minus 3 power 1 by 3 minus 10, 3 power 2 by 3. So you get f prime 3 equals negative 9.26. So this value shows that this is a decreasing function. Because if f prime x means differentiation is greater than 0, it's an increasing function. And if f prime x is equal to 0, it's neither an increasing or decreasing function. And if f prime x is less than 0, it's decreasing function. That's it. My number is 0092 0321 4080 645. Thank you.